Support for Central Florida Public Media comes from the University of Central Florida, where educators and innovators are partnering to build a bold future for Florida and beyond. From medical research to advances in space travel, UCF students, faculty, and researchers are helping to build the future. More information is at goforlaunch.ucf.edu.
Arctic upgrades on the ISS and human missions to Mars. You're listening to Are We There Yet? The radio show exploring space exploration. Hi, I'm Brendan Byrne. The space station now has a chilly addition to its cold atom lab. The Quantum Lab helps scientists study things like atoms, matter, and electrons on a deeper level at temperatures below minus 459 degrees Fahrenheit. And now, its newest module is online. We'll speak with NASA's Jason Williams about this lab and how astronauts are studying subatomic particles. Then, how moon missions are inspiring other missions like those to Mars. As we get closer to landing astronauts on the lunar surface once again, human missions to Mars don't sound so out of reach anymore. We'll speak with Explore Mars' Chris Carberry about the push for Mars exploration. That's ahead on Are We There Yet? NASA's Quantum Lab is about the size of a mini fridge, but it allows NASA and international partners to study some of the biggest physics principles. It chills atoms to almost absolute zero and makes them enter a fifth state of matter. And by studying these atoms at these freezing temperatures, scientists can better understand how subatomic particles work and behave throughout the universe. Here to talk about the lab's newest upgrade and how it all works is Jason Williams, the project scientist for the Cold Atom Lab at NASA's Jet Propulsion Laboratory in Southern California. Jason, welcome to Are We There Yet?
Pleasure to be here.
Yeah, it's exciting to have you on here to talk about the Cold Atom Lab. But before we get into that, Jason, keep in mind that the only background I have on this is watching the Ant-Man movie about quantum physics. But what is quantum physics, and why is it so important that people like you study it?
Excellent. That's a really great place to start.
Oh, good.
So quantum physics is a branch of modern physics that emerged at the beginning of the last century that really explains the physics of matter at the smallest scales. Generally, in everyday world, we don't encounter the laws of quantum physics until you're looking at atoms or subatomic particles. Well, yes, when we think about atoms, for example, generally people consider them as billiard balls that can bounce off of each other, these hard objects. But in fact, quantum mechanics says that all matter has a wave-like nature to it. And we're not just talking about atoms. Everything has a wave-like nature. In fact, you and me have quantum wavelengths that are extremely small. These wavelengths are actually inversely proportional to how massive something is and its temperature. So as you look at atoms or molecules that are lower and lower mass, the wave-like nature of the matter starts to really dominate the physics that we see. Or as things get colder and colder and colder, also quantum mechanics starts to dominate. And that's why we study quantum mechanics in the Cold Atom Lab.
So quantum mechanics are essentially the building blocks of other things, right? That's what you're looking at or looking for?
Yeah, so this is the theories of how matter interacts, and exactly it is the wave-like nature of atoms, and since atoms are the building blocks of everything, how these laws of physics come into play when you actually are in these unique regimes where quantum mechanics dominates.
Let's talk about how you study that. You mentioned the Cold Atom Lab. I'm assuming you are making atoms very cold and looking at what happens, right?
That's exactly right. And I want to give you a bit of a sense of scale of what we're talking about with cold here. So in Cold Atom Lab, we use some pretty modern cooling technologies that have emerged over the last few decades. We use actually lasers to laser cool atoms, and then trap atoms in magnetic fields to also evaporatively cool them. And with this, we've been able to achieve atoms that are cooled down to a small fraction of a degree above absolute zero. Absolute zero is, when we're talking about temperature, it's an interesting concept because this is the temperature at which, in theory, all of the particles will just stop completely. I say in theory because actually quantum mechanics says that it's almost impossible to get to that temperature due to one of the laws of quantum mechanics. That's the uncertainty principle. As you cool things, or as you cool particles more and more, they get slower and slower. And the more that you know how fast something's moving, the less certain you are in its position or in the universe. So if we could cool matter down to absolute zero temperature, we would actually not know where it is within the entire universe.
That's terrifying. Where'd it
Well,
go?
we're not quite at zero yet.
Okay, good.
But where we are is we're able to cool atoms down to below 100 picokelvin. So that's colder than 1/10 billionth of a degree above absolute zero. And when we talked about quantum mechanics previously, at these temperatures, these so-called wavelengths, the de Broglie wavelengths of atoms, are much, much larger than the classical scale of atoms defined by the electron orbitals. We're actually talking about wavelengths that are on the microns scale, approaching the size of human hair. So the wave-like nature of these atoms just absolutely dominates the physics of what we're studying in this system.
And so then you can make observations because you can now see these wavelengths? Is that what it is?
Yes, we're using this as a sort of quantum telescope or a telescope.
Oh, I like that.
Realm, to go back to the Ant-Man analog.
Yeah, I like that. I like that.
You're blowing up the wavelengths and you're slowing everything down, which makes it much easier to study these principles that are, as we say, just generally hidden at temperatures that we all know and love.
You're saying that, you are cooling these things down using lasers to very, very, very low temperatures. All of this sounds extremely complex and technologically advanced. I think we may have buried the lead here because this lab is not even on this planet, right? It is in space.
A number of labs have achieved low temperatures, very low temperatures, down to nanokelvins and below. But before Cold Atom Lab had launched in 2018, most of the Cold Atom facilities were in national labs, were in colleges. These are room-sized instruments. And we needed to bring all these technologies to cool and produce so-called Bose-Einstein condensates, a new fifth state of matter where you have a bunch of these waves that combine into an instrument that's about the size of a mini fridge. So it could fit inside an express rack locker on the International Space Station. So a lot of our early efforts were miniaturizing and using commercial parts to be able to survive launch, to be able to operate without a team of graduate students realigning lasers, and to just be able to operate remotely on the ISS, which it has been doing for over 8 years now.
You are listening to Are We There Yet?, the radio show exploring space exploration. I'm Brendan Byrne. We're speaking with Jason Williams, the project scientist for the Cold Atom Lab at NASA's Jet Propulsion Laboratory in Southern California, about upgrades to the lab on the International Space Station. Miniaturization, you may have gotten some inspiration from my movie that I watched, right?
We're always searching for Ant-Man technology.
Jason, being able to miniaturize such complex technology, fly it into space, make it autonomous so that you don't have graduate students working on it, it can run all by itself. Again, that's a lot of work. Why even do that in the first place? Why space for this lab?
We have a number of new capabilities that I would say that would emerge with bringing quantum matter to space. There are sort of two fronts. So we are exploring this for the fundamental physics program in NASA's Biological and Physical Science Division, which is within Science Mission Directorate. And if you look at fundamental physics is searches for things like what is dark matter, dark energy? Are there laws beyond, or is there physics beyond Einstein's laws of gravity? Basically, these fundamental theories of nature define the technologies that we have available to us in everyday life. For example, atomic power did not come about until Einstein's laws realized E equals mc squared, right? And we were able to access the power of the atom. So new physical laws bring new technologies. We are searching for the next generation. What physics goes beyond our foundations of modern physics, general relativity and the Standard Model, but also quantum matter can be used as a foundation of so-called quantum technologies. These are sensors that can sense gravity to extremely high level, that produce some of the best clocks that are achievable, known to man, where you can know the second to 18-digit points, for example. You really need to harness quantum mechanics in order to have these new technologies and actually bring new technologies that are critical for NASA's exploration program. And I just want to say that working with NASA, working with JPL, these are the only labs and divisions that I think can bring these technologies to space in such a critical time. And thank the International Space Station, which has been an incredible group of NASA people to work with. The International Space Station has really been an enabling platform for us, and we could not have done it without them and without NASA's Biological Physical Sciences division. So,
is there an advantage to the microgravity environment, Jason? Does that help you uncover, use this telescope a little bit more effectively?
Yeah, for multiple paths. When we go to space, and especially to microgravity, you can remove one of the most perturbing forces, being gravity, for cooling atoms. A lot of these advanced cooling schemes that we use are analogous to what you imagine cooling gases. You can decompress gases. You can go from a high pressure to a low pressure zone and cool your gases from there. We expand that, but you use generally the same principles in space. But when you remove gravity, now you don't have constraints on how much you have to contain your atom. It opens up all these new capabilities for cooling, studying atoms, achieving new ultra-cold temperatures, and also exploring space. If we're searching for something like, as we say, are there local signatures of dark matter?
Finally, Jason, what are some unanswered questions you hope that this lab will help you find?
Yeah, so this lab is a really great pathfinder. We've been able to explore atoms cooled to very low temperatures. We're hoping to look into molecular physics and produce molecules that are extremely cold, extremely weakly bound, study some of the foundations of our current understanding of quantum theory. But also this lab, I think, is really a nice launching point and a pathfinder for a series of future instruments that will go on, hopefully free flyers, future instruments that will then, yes, as we say, explore some of the big questions. Do general relativity and quantum mechanics work together? Current theories say that they do not. There's a breakdown there. And search for local signatures of new physics, local signatures of dark matter, potentially new forces that we have not been able to see on the Earth with classical sensors.
Finding new physics, no big deal. Jason Williams is the project scientist for the Cold Atom Lab at NASA's Jet Propulsion Laboratory. Jason, thanks so much for joining us.
All right, thank you so much.
Still to come, the future of human missions to Mars.
After all these years in preparation, finally are taking the steps to finally be on low Earth orbit. And we have all this commercial activity as well that's just blooming all over the place. So many capabilities we did not have when I got into the space industry.
How things like moon missions, space policy, and public support impact the future of Mars exploration. That's ahead on Are We There Yet? You're listening to Are We There Yet? From Central Florida Public Media. I'm Brendan Byrne. When we think of weather, we typically think of things like rain, lightning, or sunshine. But in space, weather looks a little different. Instead of clouds and snow, it's giant solar flares and geomagnetic storms. But while Earth and space weather are not the same, they do influence one another. We'll talk about the LASP mission and how Earth and space weather are linked on a future episode of Are We There Yet? But for now, we're talking about future human space exploration missions like those to the Moon and Mars. NASA's Artemis program is returning humans to the lunar surface for the first time in decades. These missions are sparking public excitement for space exploration and are inspiring other missions to places like Mars. So how can we get human missions to the Red Planet? What's it going to take? Questions like that will be answered at the Humans to the Moon and Mars Summit, where leaders, scientists, and space enthusiasts gather to look at the next era of space exploration. Here to talk more about the summit, future missions, and space policy is Chris Carberry. He's the CEO of Explore Mars. Chris, welcome back to Are We There Yet?
Thank you. Great to be back on.
Yeah, it's always the time of year to talk about the Humans to Mars Summit, which is a great conversation about how we are getting humans deeper and deeper into space. But before we start there, some humans did go into deep space pretty recently. The Artemis 2 mission, we had the public cheering them on and following along. How has the kind of energy and momentum from Artemis 2 shaped the conversations that are going to be having at the Humans to Mars Summit?
Oh, enormously. Of course, first time back to the moon, even going around it in over 50 years. So finally, after we've been talking about going back into deep space, leaving low Earth orbit, we've finally done it again. And I think it really has energized the entire space industry, but also the world. We're living in a time, as you know, where, with this polarization, there's kind of just differences of opinion internationally, but everybody's on the same page with the excitement. This is what's so wonderful about it. Space exploration in general, it's nonpartisan. It brings everybody together. Internationally, everybody's excited about it. So it's one of these things we should really embrace, because there are very few things these days that brings everybody together. Everybody's excited about. So we need to grasp onto it and just move forward with that.
Chris, I cannot remember for how long we've been talking, but I know you've been on the show for quite a few years. And when we first started talking, that humans in deep space was always the horizon goal, right? We were almost there. And then we see Artemis 2, right? Tell me about it personally for you. What was that moment like? You've been thinking about this for a long time.
Well, of course, I remember back when I got involved in the space industry, in space advocacy. This was over 25 years ago, to age myself. And of course, we had all these PowerPoint presentations and pre-PowerPoint presentations talking about what we'll need, and maybe in 10 years, and then another 10 years. And we used to in 2000, we had these signs that said, Mars by 2020. Well, we didn't get there, but after all these years in preparation, finally are taking the steps. We're finally beyond low Earth orbit. And we have all this commercial activity as well that's just blooming all over the place. So many capabilities we did not have when I got into the space industry back in the late 90s, early 2000s. And so we are so well prepared to really start this voyage now and hopefully just bring all of humanity with us.
With that voyage underway, what conversations are going to be had this year at the Humans to Mars Summit?
One of the key ones I'm looking at, obviously, we're going to highlight the excitement, talk about Artemis 2 and subsequent missions. But one of the things we also want to talk to, as NASA recently mentioned in a recent news conference about their plans for the moon base. And that's terrific. We're excited about that. We're also going to talk about making sure that we don't lose sight of Mars. We understand, yes, most of the focus needs to be on the moon, because that's our first goal, to get there, start building permanence on the surface of the moon. But we also don't want to lose sight of Mars. We want to make sure to use the surface of the moon as much as we can to enable future missions to Mars. And it may seem obvious, because a lot of the stuff we'll be asking for will be done anyway on the surface of the moon. But unless we're very deliberate about it, unless we're planning it and using that information in real time and thinking about it in terms of Mars, we could actually find ourselves in another 20 years thinking, all right, now let's start planning for Mars. And that's still another 20 years away. So we don't want to be in that position. We want to make sure that we can do as much in parallel as possible and truly utilize the moon to enable Mars, hopefully by the end of the next decade. So we'll be having a lot of conversations on that specifically, but also things like what will it take, like biomedical needs, how we're going to protect the human body and mental health, talking about the innovations required for creating sustainability, all aspects, of what it'll take to successfully go from the moon onward to Mars. It's not just about the big rocket companies, which is one of our big primary message. It's going to take a huge number of different innovators and players around the country and the world to make this possible. It's great when you see like Starship take off, but if those astronauts, no matter how many astronauts are on board, they still have to breathe. They have to eat. They have to have, be able to figure out how to keep themselves healthy mentally and physically. It goes on and on and on and on. And that's going to take a lot of different players. So that's one of the areas we love, because we also like highlighting how these innovations can benefit life here on Earth.
Those pesky human needs, right? They get in the way of exploration, don't they?
They do. They expect us to breathe and eat and drink and be happy too.
You're listening to Are We There Yet?, the radio show exploring space exploration. I'm Brendan Burnham. We're speaking with Chris Carberry, CEO of Explore Mars, about the future of exploration on the Red Planet. So, Chris, you mentioned something that I want to just dive into a little bit deeper. Setting up the moon for us to go to Mars. And, I know that this is really about how we communicate this or frame this, but, there was always a lot of talk about it's going to be the Moon to Mars program, right? But the way NASA's talking about its lunar ambitions now, we're returning to the moon, and this time we're there to stay. Is there concern that Mars is being forgotten in the Artemis program?
There is a concern. Now I've certainly heard, like, for instance, Jared Isaacman, during that actual news conference I mentioned, when asked, he did mention that the reason we're doing this is to enable Mars. And that's great. It was great to hear that. But once again, I think as a community, there is a tendency in NASA and any federal agency, any program where you have a very specific goal you're trying to get done, there is a tendency to have tunnel vision and focus on it because you want to get it done, as we want them to get it done. But I think as the community, Explore Mars, other organizations, members of Congress who support it as well, and elsewhere, we need to make sure to keep up the pressure to remind NASA, remind the partners that this really is, I think we all truly believe it is Moon to Mars, or Moon and Mars. And so what can we do? And not all of this takes a lot of money. And this is where, like what I was alluding to earlier, that for going to the moon, and we are actually, not everything is applicable to Mars, but a lot of it is. And there are things we're going to be doing anyway. Let's make sure that we deliberately think about it in those terms as we're learning about these things, learning about logistics and other things. Let's make sure that this is part of the program to specifically use it in Mars planning. But it's not just that, because there are other things. There are things called long poles, technologies, capabilities that take more than a few years to get done. Things like entry, descent, and landing, which most people say is the most challenging long pole for Mars, getting through the atmosphere and landing successfully on the Martian surface. The most we've ever landed is 1 metric ton, and that was about the Perseverance and Curiosity landers. But we need to, at minimum, if we're landing people, we need to land 20 to 40 metric tons. If you're SpaceX, a lot more. And so if we can do some of these things in parallel, testing out EDL technology, landing, maybe ascent technology, and if we're doing that, try to do some of the other things, some of the science goals, bring back a lot of samples. If we're landing a larger vehicle, testing this out, bring back a large portion of samples, test ISRU. If we're going to do it, we want to do it efficiently as well. We can find ways of doing it. And it's not even just those big missions, but for instance, the recent Escapade mission that went up on Blue Origin a number of months ago, there was a collaboration between Advanced Space, UC Berkeley, and Rocket Lab. Inexpensive public-private partnership, 2 small satellites in a novel orbit to make sure so they could launch it in an off year, not the usual 2-year Mars window. And those sorts of things, we find that combination of less expensive small missions, and then if we're testing larger stuff, try to make sure we're doing it as efficiently as possible and make sure there's good integration between NASA's directorates, its partners, and academia to make sure that if we're going there, if we're sending larger mass down there, what else can we do so we don't miss an opportunity and realize, oh, now we need to send another mission because we forgot to do that.
And Chris, that innovation is at risk with congressional funding appropriations, right? As you wrote in an opinion piece for The Hill, leveraging Artemis 2 means rejecting NASA budget cuts, right? All of that stuff that you outlined could possibly be wiped away with this budget proposal, right?
Oh yeah, no, it's while human space flight, gets funding on this, I don't think they understand the importance of the science budget. Now, this was, of course, all across the board, 23% top level cut to NASA's budget, about 46% cut to the science budget, and that would be just decimating it. This is very similar to the proposed cut last year, but thankfully Congress overrode that and restored NASA to full funding. But of course, the same basic cuts were offered this year as well. And while Congress is probably going to reject them again, this is not the way to run a successful mission. Particularly, and this, what was really ironic about it was it literally came like a week or a few days after the successful landing of Artemis 2. So we have this tremendously exciting, historic return to the moon. And what do we get? We get proposed huge cuts in NASA's budget. So it didn't really align. And so we need to make sure that Congress and the administration understand that particularly the science part is important. We still need to understand the science of Mars, but also the rest of the solar system and the universe. The United States has led this for decades. It has, produced enormous amount of understanding of soft power within the United States and respect around the world. And this is one of the areas I mentioned, the soft power aspect. You can't dismiss that because people still look at NASA, even though they have their own space agencies, they still look to NASA for leadership, NASA for inspiration. Even with all the private sector activity, NASA's still at the center of that, and you do not want to lose that. And our science portfolio is key to that. It's been extraordinarily successful. We're leaders in the world, and if we don't fund it, others will take it up and take that mantle of leadership in science and innovation. And that will have a direct impact, trust me, on human exploration as well, because we're going to be losing those areas of understanding of the universe, the planetary science, and other areas which directly connect with, enabling sustainability for humans, away from our own planet.
Chris Carberry is the CEO of Explore Mars. The Humans to Mars Summit begins July 21st. Chris, thanks so much for joining us.
Oh, thanks for having me.
That's going to do it for this week's show. If you're not already, be sure to subscribe to the show's podcast feed so you never miss an episode. Do that on Apple Podcasts, Spotify, or wherever you get your podcasts. Stay connected with this show. Follow us on social media. We're on Instagram and Facebook at AWTYSpace. If you got an idea for a future episode of the show, or you want to join us as a guest, reach out. Our email is arewethereyet@cfpublic.org. Are We There Yet is a production of Central Florida Public Media. Our producer is Marion Summerall. Editorial guidance comes from LaToya Dennis. Support for Are We There Yet comes from our listeners. Until next week, I'm Brendan Byrne. Thanks for listening.